My model predicted that Birkeland currents uniquely produce coaxial counter-rotational motion of their internal plasma and are able to carry electric current in both directions at the same time. Let me emphasize, this is a unique behavior. A coaxial cable here on Earth cannot simultaneously carry current in both directions. As far as we know, true coaxial counter-rotation is created in nature only by field-aligned, that is to say, Birkeland currents. For example, a pair of tornadoes located near each other, rotating in opposite directions, is not an example of coaxial counter-rotation, simply because they're not coaxial, they're not inside one another. So when NASA recorded those coaxial counter-rotating cloud bands on both Jupiter and Saturn, my model had passed its first test. That was the extent of my first foray into this cosmological jungle, and at that point I figuratively pitched camp for a rest. But then announcement of the discovery of counter-rotating stars in the faces of several spiral galaxies was even stronger evidence I was headed in the right direction. In 2014, it was reported that a vast network of plasma filaments, Birkeland currents really, had been discovered that connects many, if not all, the galaxies in the universe in what has been called the Intergalactic Web. The discovery was quickly confirmed, and a rush of scientific papers followed. All this strongly suggested that Birkeland currents not only connect objects within our solar system, but there are much larger and stronger Birkeland currents arching across the vast distances between galaxies. I assumed that those galaxies within the intergalactic web must be sending and receiving electric currents via the plasma filaments to which they are connected. Also, I thought if galaxies actually form on those Birkeland current filaments in the web, they probably inherit their rotational profiles from those filaments. If that happens, then the stellar velocity profiles ought to be the same as the velocity profiles of the Birkeland currents on which they form. Remember that the typical stellar velocity profile in a galaxy has been totally baffling to astrophysicists. Actually, they typically look like a plot of the function the square root of r. This shape cannot be explained by Newtonian physics, and almost all astrophysicists deny that electrical effects could possibly produce any of what we see in the cosmos. So that's why astronomers like Vera Rubin and her colleagues postulated the existence of dark missing matter in the 1940s. Their repeated unsuccessful attempts to explain this rotation of those stars is what set astronomers off on their decades-old quest to find dark matter.